All right, so this is the intro lesson to Pre-Calculus 30. We're starting chapter 1, and we're talking about function transformations, okay? So you guys know what functions are. Functions are graphs, right? X, Y, a bunch of points. They can be straight lines or curves, anything like that. And transformations, in this first chapter, we're talking about how the graphs can be altered. So the parameters of the graphs can be altered. So they can be like stretched, or they can be moved up or down, left or right. And so what are the parameters for functions that we can change kind of their position or their orientation or how they look and how they're stretched? So that's what this is all about. And you can see in this picture here, look at these, look at the windows here on this building. All right, so there's a good chance that this window pane right here and this one right here are identical glass window panes, right? But from our perspective, this one looks like totally different. Why? Because it's kind of stretched. It's kind of transformed a little bit, right? And so it's squished up a little bit. It's not as wide, and it's kind of got a little bit of a tilt to it, right? And so parameters have been changed from our perspective to make this look different. And even these glass panes right here, see how they kind of look different than these ones, but they're probably all the same. So that's what we're going to be studying, how on a graph we can transform, right, into one graph looking something a little bit different. So what we're going to focus on first is horizontal and vertical translations, okay? So horizontal, obviously you think about the horizon goes sideways, left to right. And so a horizontal translation, if you think about what does translate mean, right? If you have an English statement and you're translating it to Chinese, right? Something like that. It's the same thing, except it's altered, it looks a little different, right? So we're going to take the same function and we're going to just move it. So just like one language to another language, we're going to move it horizontally and vertically. So we're going to test to see which parameters cause these kind of transformations, okay? A translation is a specific type of transformation. All right, so this is what I want you to do. All right, so with your graphing calculators there, I want you to plug in this right here. Y equals the absolute value of x. And for those of you that have a TI here, I'm going to show you kind of how that works. So you're going to go to y equals, you're going to clear off everything that's already there. Now to get the absolute value, I believe you have to hit the math button. And where is it? Number? Yeah, right here. So math, go over to number, the number category, and ABS with a bracket, that's absolute value. Okay? So you go, again, you go to math, and you go cursor over 1, and just hit enter. And you get absolute value. So then put in your x value there, close that bracket, and then we'll graph it. And you should have a graph that looks like this. Okay? All right, so if you're able to get this, now absolute value, let's just comment a little bit on absolute value, okay? Some students are really mixed up by absolute value. We don't talk a lot about absolute value in classes up to this point. But look at this. This is very similar to this one, y equals x, right? Now y equals x looks like this. This is y equals x, where every point on here has the same x and y value. That's what that means. So we have 2, 2, we have -3, -3, and all this. If you have an absolute value here, okay, that means that whatever input value you have for x, the absolute value basically takes away a negative, right? It makes it positive. So if x was -2 to begin with, well, now it has to be, the y then turns into +2. So you can't have any negative y value. See, y is absolute value of whatever the x is. And so that's why you get a reflection this way. And so your graph then for absolute value looks like this. That's where you get that little V shape. Okay? All right, now this is what I want you to do. I want you to take a few moments, and I want you to put these ones also in your graph, one at a time, if you want, one at a time. So do absolute value of x now +3. And I would suggest leaving this graph on the screen so you can compare what adding a 3 outside here does and what subtracting a 3 does. So take a moment, to do that on your calculator, and we will we'll take a look at that in a second for you, okay? Okay, so while you're putting these in, okay, and hopefully you've done a few here now, but when you see how these graphs are changed, I want you to think about and even jot down some observations. So what does this adding 3 do? What does this subtracted 3 out here do? What happens if you put that plus 3 inside the absolute value signs, right? That's what we're exploring. So what have we noticed so far? What are the observations so far? What does this plus 3 do here, the first one?
Changes the y-intercept.
Okay, it changes the y-intercept. Good. Does it go up or down, the y-intercept? Yeah, it does. And where does it go up to? Yeah, it goes up 3 units. And so your graph should look something like this, right? So that's the second one. Okay. Now, what does the minus 3 do? It takes the graph and moves it down 3 units. Yeah, okay. So this is what you should be noticing, that these numbers outside here should move the graph up and down. Now, I'm going to show you on a little bit different platform. This is called Desmos. So I'll be using this quite a bit this semester. All right. I've got y equals the absolute value of x shown here. Okay. Now, I've got it written the exact same way, but I've got some added parameters here. Now, watch up here. So this k right here. Okay. So this is absolute value of x. And I've provided for a number here and a number here. And I've put these little sliders on here. So I can change the value for k. So let's say, now I'm going to leave this one lit up. Let's say that I want to move this k value to, what was it on yours? Absolute value of x plus what? What was the first one? 3, right? So there you go. Look what happens there. It moves up to 3. Perfect. Okay. Now let's just take a look at I want to move this slider. So what about 2? Well, if it was a plus 2, look at that. The intercept is 2. If k was a minus 3, like you guys did, it goes down here to minus 3. See that? So if you play around with this k value over here, as it goes up, so does the graph. Right? You see that? So that k value over there moves the graph. It translates it up and down. Okay? All right, so let's go back to 0 there. And let's explore what happens now when we change the parameter inside the absolute value sign. What did you guys find? What happens to that graph? It changes the x-intercept, right? It moves it horizontally. Very, very good. So I'm going to go over to Desmos here, and I'm going to show you how that works. Now, see, I've programmed this h to be that parameter. Now, don't worry about the minus and the plus here. I'll talk about that a little bit later. But if I move h to be a positive value here, it's going to move the x-intercept. If I move h to be less than 0, it's going to move the x-intercept accordingly. So when there's a number inside this absolute value function with x, that changes the x coordinates. Now watch this. If I had a number that changed the x coordinate as well as the y coordinate, look what happens. The graph changes in both directions. Okay? So it can change left to right or up or down, no problem. So check this one out. If k is minus 1.67, that means that the y-intercept has gone down to 1.67. That makes sense. If h is 8.33 inside here, so that looks like x minus 8.33, the x value has moved 8.33 units to the right. Okay? So again, I can move it left to right with the h value. I can move it up or down with the k value. Isn't that awesome? That's like teacher awesome. I know it's maybe not teenager awesome, but that is awesome. Okay, so we're learning some things here. We're learning about the parameters that affect vertical and horizontal translations. Very, very important. Okay, so let's talk about this. What is the translation versus transformation? We talked about it earlier, but here's a chance for you if you want. You can write this down in your notebook so you have it all together. This is in your textbook as well. Okay, a transformation on the larger scale is a change that is made to a figure, or in our case like a function, right, or a relation, such that the figure or the graph of the relation is shifted or changed in shape. So a transformation is a shift, either left, right, up, down, or a change in shape, which would be like a stretch or a compression or a flip around or something like that. That's what a transformation is. Taking a basic function and changing its parameters to make it look like something slightly different. A translation is what we're focused on in this section, and that is a slide transformation that results in a shift of a graph without changing its shape. And that's important. Notice that in our examples, that absolute value of x, it did not squish up like this, right? Or it didn't flatten out. It was the exact same shape, just moved up, down, left, right, whatever, right? So that's important. Now, here is a look at two different ways that they can show you how these transformations happen. And this is going to be it right here. And I want to focus on this format right here. Okay? So I want you to write down y minus k equals f, and this would be the function f, bracket, x minus h. I'm just going to highlight a few things here while you do that. Okay? So this is the basic format, okay, for indicating vertical and horizontal translations for a function. Now, you may notice this looks a little different than what we did. We had to graph ours on the graphing calculator, which means that we have to have y equals. So this is what we did. We did y equals the absolute value function f, okay, and we had an h value in here, and then we had a plus k over here, right? That's what ours looked like. And this is the exact same, because if you add k to both sides, right, this is what you get. That cancels out. And so this is how we put this into the calculator. And honestly, you're going to see this a whole lot of times where just the y is by itself, okay? So both of these are correct, but they look just slightly different. And of course, as they introduce this, you see how they have y minus k here equals f of x. That's the way they introduce it, so it's important for you to understand that really it's the same thing. Okay, so this part right over here is the vertical up-down translation. This number right here is the left-right translation. Okay? If k is positive, it goes up. If h is positive, it moves right. The tricky part here is, guys, now watch this. The format, and I'm going to write this with our absolute value function, okay? The format is like this. This is a plus k out here, and this is a minus h in here. And what that means is that when you look at an equation, and so let's write y equals, which is one of the ones we did, absolute value of x plus 3, right? That means it's a plus k and it's a plus 3, so this is up 3 units. Because it's a plus here and a plus here, that's a positive k, a positive k. The slightly confusing thing, which you guys will have to just make sure that you be aware of, is that when we talk about inside the brackets, okay, inside the brackets, because the format is negative, see it's a minus here, that means that this actually is that a positive 3 or a negative 3? Well, if it shows up as minus inside the brackets, that means that h is positive. So it's kind of like an opposite. This moves to the right 3 units. Okay? So you may have seen this before in Foundations 20 or Pre-Cal 20, that inside the function here, if this is minus 3, that means it moves right. If it's plus 3, it moves left. So it's a bit opposite inside there. Okay? And we'll double check that. Now, this is a bit funny here, right? Because we're talking about h is a positive number, so this would show up as x minus 1.9. See that? That would be x minus 1.9. And so that's moving from 0, that's moving to the right. So x minus 3.4 would move it to the right 3.4 units. X minus 5.3 would move the graph to the right 5.3 units. So it's just kind of how it shows up. All right, any questions so far? All right, let's talk about mapping then briefly. Mapping. So this is mapping notation. And what mapping notation shows us is what happens to the graph and how the parameters change each point. So remember, you have the point xy for your original graph. It's just xy. So when we do a horizontal translation, that moves left, right. That's the x coordinate. And so whatever your h value is, you would just simply add that to each x coordinate. And that's how you get your new graph. So if h is 3, you add 3 to every x value, and that's your new point for the new graph. It's called mapping notation. And also, whatever k is, we add that to our y value to get the new values for the new graph. Okay, so let's just talk about what we've talked about here so far. Let's just do a little bit of a review here, okay? So we're talking about transformations. The first transformation we're talking about is any function. We're using absolute value for x function, but it really can be applied to any function. We'll do a couple more examples as well. But you can move any function left or right by affecting the value inside the, where is it? Right here, value inside the function. So anything that's added or subtracted to x will move it left or right. Anything that's outside of the function right here or attached to the y value moves it up or down. So if you have a situation where you have y equals f of x plus k, then it goes k units up. If it's minus k, it goes k units down, and so on. So left, right, up, down. So you'll see that they, down here, they put kind of both ways to show it. Y equals f of x minus h plus k. So what I'd like to talk about is just other functions, like other graphs that we can move and what that looks like. Okay, so I'll just kind of maybe end with that. So what about, let's do this. So just write this down. Y equals x squared and y equals 2x plus 1. Okay. So those graphs look like this. We shouldn't need to graph that in the calculator to know what these look like, right? We should know this. This is a quadratic function. And of course, it's a quadratic function. It looks like a parabola. And the vertex is here at 0, 0. Okay, excuse my rough drawing here, but it's a smooth parabola. And the vertex is at 0, 0. We know that. This one over here, y equals 2x plus 1, is a straight line. It's a linear function. It's got a slope of 2 and an intercept of plus 1. So here's plus 1. We go 1, 2 over 1. It's a straight line. That looks like this. Okay? So we should know how to graph that or do a rough sketch of those. Okay. So let's see what happens. Now I'm going to go back to Desmos here, okay? I'm going to go back to Desmos. And I'm going to take a look at this first one here. Let's get rid of that. Let's get rid of that. Okay. So let's set k back to, well, k is going to be 0, really, right now. And you can see kind of even what's happening as I move this, right? So to exactly 0. Okay. So there is our parabola, right? It's y equals x squared. I've got k and h equal to 0 and 0. Does that make sense back here? There's nothing subtracted or added to x inside this function, and there's nothing added or subtracted out here. So there would be zeros both ways. Another way to write this would be y equals x minus 0 squared plus 0. Does everyone see that? Okay, so I haven't shifted this over at all. This is the same as this. That's written in our format. The function is x squared, so look at where's x squared here? Well, it's right here, right? X squared. You can kind of see it. I was going to use a different color there. Let's see. X squared. That's our main function. It's hidden in there somewhere. Okay. So let's change some parameters here. Well, let's go back to decimals. Let's make k inside here. Let's make it a positive something. What happens? Oh, sorry. Sorry. Where am I? K is this one. Sorry, not this is h. K. Let's make it a positive something. See, it moves it up. You see that? So positive k moves it up. 0. H inside here, positive h moves it to the right. So that's x minus 2.3 moves it to the right, 2.3 units. Okay, moves it to the right. So this parabola right here would be, the equation for this would be y, okay, well, let's go back here. Y equals, let's try this one, x minus 2 squared plus 3. Okay. If I were to draw this one, I will draw this one later. Let's draw it on here. So this one is going to go, the x, any x value, let's take the vertex, is going to go to the right 2 units, guys. Okay? To the right 2 units. And the y value, this is the k value, is going to go up 3. So 1, 2, 3. That's going to be our new vertex. You see that? That's what this one should look like. Okay. So let's just see if we can see if we can get both of these going at the same time here. Okay. So for this one here, and you know what? I'm actually going to put the plus k over here. There we go. And let's see if we can do what we just did here. So x minus 2, so it's x minus, that's going to be a positive 2. Whoops, the h, sorry. Positive 2, there we go. 2. And it's going to be a plus 3, so k has to be a plus 3. There we go. So you see how that works? Over 2, up 3. For this format. Make sense? Yeah? Okay. Okay. Now, just really quickly, let's just finish off with this one. It's a straight line. So how are we going to move this straight line up, do you think? How are we going to move it up? Well, let's add, I guess up 2 units or 3 units. Let's add 3 here. See that? Just add it outside of where the x is, along with this. So now this becomes 2x plus 4. That will move this up 1, 2, 3 units. It'll be the same thing, up 3 units. Okay. Now left, right is a little bit trickier. How do we do that with the x value? Well, remember, it has to be something like right alongside, right in with the x here. So let's try this. Y equals 2. Let's try that. What is it going to be? 2x minus, let's move it to the left or to the right 3 units. Is this what it's going to look like? Or do we have the brackets? Do we have the brackets on this side of the 2? Right? What's it going to be? Where do we put that 3? So what I want you to do is to try this on your calculator. All right. So here's what we're going to do. This is the final sort of exploration before I set you off on your assignment. I want you to write 2x plus 1 in your calculator. Y equals. Okay, get rid of whatever you got there now. To 2x plus 1. Okay, you're going to graph that. And I want you to move this graph over to the right 3 units. And so I want you to tell me, is this the way you would write it? Or would you have to put the brackets, instead of here, would you have to put the bracket there? You tell me. Okay? So do that exploration. Let's see what it does. Take a minute to do that. Okay, so you should have those three in there. I'm gonna make one here in Desmos. I would encourage you guys to use Desmos. It's really nice, especially with the sliders. It's really, really cool. Oops. So what am I going to do here? I'm going to do 2 bracket x minus. I have to do. Yeah, I can do h, I guess. X minus h. Okay, so we're going to try this one. Plus h plus k. So k is 0, h is 0, and we'll get rid of this one. Okay. Okay, so k was 1. Okay, so good for you guys. All right, so this is what you should have in your graphing calculator. I want you to have kind of all 3 of these going. Now, you want to test whether the bracket should be there or here, right? So is this the one that moves the whole line to the right 3 units, or is it this one here? And so when you do the graph, this is the original right here. So if you hit trace, you'll see a blinking cursor and then the equation that it's actually on. And so that's the original. If I go over one, or maybe I should go, there we go. This next line right here is this one. So when I put the bracket out there, does that move this over 3 units? It looks like it moves over maybe closer to 1 unit. But if I go to the next one down here, this graph right here, see? Okay, so this is going to be closer to 2.5, so that's minus maybe 0.5 to 2.5. So that's the one that gets it 3 units. So it is actually this format right here. Okay, so if you want to move it horizontally, it has to be right with the x, not in with all this number right here. And on Desmos, this is what it looks like. So here's our format, and right now we have y equals 2x minus 0 plus 1. That's what this original graph is. And if I move the h value here, if I go to 3, then it's going to move that graph over 3 units from where it was. Okay, 2.5. And if this was 0 again, this is negative 0.5. Okay. Okay. Any questions there? Okay. Exploration with vertical and horizontal translations. Okay, so there's your suggested homework right here from section 1.1. And I do have a video for question number 1 if you get stuck. Check on your Google Classroom, on Mr. MathWell channel. You can check, and I worked through this, number 1 at least, I think, with you. So if you're having any troubles, you can check that video out or ask me questions when you see me. Okay, and here is what the textbook will look like for as far as your questions go.